All right, here's our third video in section 10.5. In this video, we're going to be rationalizing some denominators. Now, we've rationalized denominators before. Remember, rationalize the denominator means to get rid of the radical on the bottom. But all the ones we did before only had one term on the denominator. There was one piece, it had a radical, we wanted to get rid of that radical. Do you remember that we multiplied both the top and the bottom by that radical? Or however many factors we needed to bring out the groups to get rid of the radical, and that's how we were able to rationalize the denominator if there was only one term. But what happens if there's two terms on the bottom, two pieces, and maybe one or both of them have radicals? Well, what we're going to do is we're going to use conjugates. Remember, conjugates are the opposites. We talked about that in the last video. Conjugates allow us to rationalize denominators if there's two terms underneath. Let me show you. Looking at example number 4, it asks us to rationalize each denominator. You notice in A, there's a 4 minus the square root of 5. There's a radical in that denominator. But there's two terms here. There's a 4 minus rad 5. We want to get rid of the radical, and we're going to do that by multiplying the numerator and the denominator, both the top and the bottom, by the conjugate of that denominator. So if the denominator right now is 4 minus rad 5, then the conjugate would be 4 plus rad 5. I'm going to multiply the top and the bottom to keep my equation balanced. You notice that I put parentheses to kind of symbolize that I have two terms connected with a plus or minus sign. What we're going to do now is just like fractions. We're going to multiply tops with tops and bottoms with bottoms. Multiply across the numerator and multiply across the denominator anytime we're multiplying fractions. When I do that, I want to take the 5 and distribute it into everything inside these parentheses. So I'm going to do 5 times 4, which is 20. And 5 times the square root of 5. Remember, outsides go with outsides and insides go with insides. So I end up having 5 rad 5 on the top. 20 plus 5 rad 5. If you look at the denominator, I have a binomial times another binomial. That means we really have to FOIL the bottom. I'm going to do 4 times 4, 4 times the square root of 5, negative square root of 5 times 4, and negative square root of 5 times positive square root of 5. When I do that, 4 times 4 is 16. 4 times the square root of 5 is 4 rad 5. Negative 1 rad 5 times 4 is a negative 4 rad 5. And then a negative rad 5 times a positive rad 5 is a negative rad 25. Hopefully you got those same terms that I did. Now when you look at the terms in the bottom, I don't know if that got rid of radicals or just added a whole bunch of radicals there, right? But it should have. Look, as long as you multiply by the conjugate, your two middle terms should always cancel out. We talked about that in the last video. You see, you notice that we have a positive 4 rad 5 and a negative 4 rad 5. Those zero each other out. So I have less radicals. Now I still have this square root of 25, but wait a second, isn't there an even square root of 25? Isn't the square root of 25 just 5? So really, on my denominator, I have 16 minus 5. I have no more radical. I've just rationalized my denominator. We can simplify it a little bit more because what's 16 minus 5? Isn't that 11? So on my numerator, I have a 20 minus 5 rad, or excuse me, 20 plus 5 rad 5, and my denominator, I just have an 11. No more radical, I've rationalized my denominator. All right, let's look at B. B looks a little bit different than A because I have two terms on the denominator and I also have two terms in the numerator. But we're going to do the same thing. We're going to get rid of our radicals. We're going to rationalize our denominator by multiplying both the top and the bottom by the conjugate of the bottom. So if my denominator right now is the square root of 5 minus the square root of 2, then multiplying by the conjugate would mean I'm going to multiply by the square root of 5 plus the square root of 2. Make sure you do top and bottom so you can keep your equation balanced. That means I have two binomials on the top, I have to FOIL, and two binomials on the bottom, I have to FOIL. So why don't you pause the video, see if you can FOIL the numerator and FOIL the denominator, and see if you end up with the same terms I do. This is a good place to pause, try it, and make sure that you're understanding. All right, when I FOIL, remember outsides go with outsides and insides go with insides. I ended up distributing through the 4, and I got 4 rad 5. I distributed the rad 2 through, and so I got a 4 rad 5 times 4 rad 2. I have a rad 2 times a rad 5, which is rad 10. And I have a rad 2 times a rad 2, which is rad 4. Hopefully you got the same things I did in your numerator. In my denominator, when I distributed through, I ended up getting the square root of 25 plus the square root of 10 minus the square root of 10 minus the square root of 4. And you notice, as long as we make sure we multiply by conjugates, these two middle terms cancel. Also, you may notice that the square root of 4 is really just 2. And the square root of 25 is really just 5. So in my denominator, I have a 5 minus 2, or can we say 3 in my denominator? No more radical, right? Now what's going on in our numerator? In my numerator, I have a 4 rad 5, and rad 5 can't be broken down anymore. I also have a 4 rad 2. It also can't be broken down anymore. I have 1 rad 10, which I tried to break down, but I didn't have enough partners to come out, so it can't be broken down anymore. But I do have the square root of 4, which is really just 2, correct? So I have 4 separate terms in my numerator. None of them are like terms. They all have different stuff. So my numerator would just be 4 rad 5 plus 4 rad 2 plus 1 rad 10 plus 2 all over my denominator, which remember was just a 3. I've got rid of my radical on my denominator. I've rationalized my denominator, and I've combined any like terms that I can. So it looks like that would be my final answer. All right, let's do one other example in this video, and let's talk about what happens when we have different radicals, different indexes. You notice on this one, it's asking us to divide, and if we can, simplify. However, my numerator has a fifth root, and my denominator only has a square root. Remember, we can't multiply or divide radicals that aren't the same. But then what's the point of this question, right? Well, we must be able to do a little bit of something. So here's what we're going to do. We're going to take it out of radical form. You remember taking it out of radicals and making it into a fraction, a rational exponent? Remember, top dog goes in the house? Let's go ahead and do that. Use that technique and our rules for exponents to see if we can combine these any more than they already are. Remember taking the fifth root of y minus 9 cubed. If top dog goes in the house, when I go to convert it into rational exponents, that 3 would be my numerator and the 5 would be my denominator. So I can really say that the fifth root of y minus 9 cubed is really the same thing as y minus 9 to the 3/5 power. Now look at your denominator. Your denominator really has an invisible exponent of a 1 if you want to think of it that way. So if I want to take the square root of y minus 9 to the first power and convert it into rational exponents, then it would really be y minus 9 to the 1/2 power. Now, they both have the same bases. They both are y minus 9s. And do you remember your rules for exponents? That when we divide, we really subtract the exponents? The problem is I can't really subtract these two fractions because when I'm subtracting fractions, remember we need a common denominator. So in order to subtract the 3/5 minus the 1/2, I need them to be the same denominator. So let's go ahead and convert them into the same denominator by multiplying 3/5 by 2 over 2 and 1/2 by 5 over 5. When I do that, I end up getting y minus 9 to the 6/10 over y minus 9 to the 5/10. You notice that they now have common denominators of 10. Same exact value as my original, just in a different form. But at least now they have common denominators and I can subtract the exponents. I should be able to combine my bases just like I've done in the past. When I divide, I subtract the exponents, so 6/10 minus 5/10 really gives me 1/10. So now I have the expression y minus 9 to the 1/10 power. I was able to combine these even though originally they weren't the same radical. I can convert it into fractional exponents, make those fractions have a common denominator so that I can actually combine them together. But now let's go ahead and convert it out of rational exponents and back into radicals because that's how my problem started. If I have radicals to begin with, I probably want to have radicals to end with. So if I have y minus 9 to the 1/10 power, and it's a fractional exponent, what would that look like as a radical form? Remember, top dog goes in the house, so I should be able to take that one, put it inside as my exponent, and use the 10 as my new index. So I can really say that the fifth root of y minus 9 cubed divided by the square root of y minus 9 ended up being really the 10th root of y minus 9. I had to do a lot of work to get there, but I was able to use all my different techniques that we've learned in the past to convert and our exponents to be able to combine these two terms.